One, two, three, mic testing.
How the world is moving today, right? There's a lot more expectation that people have or the users have.
Welcome to Analytics India Magazine's podcast, Simulated Reality. I'm Tausif, and today we have a guest from Western Digital, a data storage company. We have Bharat Belavadi from Western Digital, who is a Senior Director, Advanced Analytics Office at Western Digital. Uh, Bharat, welcome to the podcast, and please introduce yourself and take us through the development which is happening in the storage and industry.
Great. So first of all, I'm very happy to be here representing a data storage company. Especially when you look at analytics, I kind of make it as a cube which has three dimensions, right? One is about plain algorithms and statistics that you use. The second is about the storage that is needed, and the third is about the computing power, right? So I'm very happy to talk about the second dimension, which is storage, in this podcast. Um, just a quick introduction about myself. I head the Advanced Analytics Office in India. So we are a global team, which is part of the corporate function of IT, and we do a lot of advanced analytics within this space, including the data science, which is kind of a first of a kind solution modeling. We also do some advanced mathematics, which is operation research, as well as the digital twins and the simulations in the manufacturing industry, right?
Okay. Okay.
Now, going to your question about just knowing what is happening within the data storage industry, right? I would like to frame it in terms of how the world is moving today, right? There's a lot more expectation that people have or the users have in terms of high storage, high compute in the edge solutions, right? We still have a lot of data storage requirement in terms of our data centers or any personal equipment that you have to store the data or the devices, but there's a lot more expectation in terms of cloud as well as edge, right? Before I get into that, I want to give you a little bit idea about when we say storage, data storage, what we really mean, right? So the data storage can come in multiple forms as devices. One is the traditional way, which is hard disk, which is a mechanical, there is a media file that runs and then you read and write the information on that. The second is the solid state drive, which is essentially, it doesn't have any moving parts. So has a memory, it has a controllers, and it stores the data. And the third is, which most of the people use, is the USB flash drive, yes, right? So where you store the data and it's more of a removable device. And a lot of memory cards, which goes into your cameras, GoPros, the one that you're recording now, everything is driven through those micro SSD cards. And we also have other products in terms of network, attached storage and embedded flash, which goes into your mobile phones and a lot of tablets and PCs and so forth, right? So there's a wide variety of storage devices that we talk about in terms of the data, right? Now, from the industry perspective, yes, there is a lot of movement towards or the focus towards cloud as well as the edge. Just look at the advent of the 5G network that is coming in, right? So there will be times where people will download a huge amount of data onto onto their phones, to their watches. There are so many devices that are going to get connected with 5G. So a lot of data needs to be stored at the edge. And we are focusing on, building some of the products that is essential to make, those edge devices run. And one more thing that I would like to add is also the data storage industry is now. I talked about the cloud, right? Serving a lot more hyperscalers like the AWS or Googles of the world with the data storage requirement, where you cannot just have a lot of devices in terms of SSD and HDD taking up your rack space. So you need to come up with ideas and innovations on how you can store more with less. So I would like to summarize with like 3 or 4 factors which I say that is most important from a data storage industry point of view. One is in terms of accessibility, right? So that means you're expecting the data to come immediately, you no longer want to wait for even a second these days, right? Gone are the days where it was seconds, then it came to milliseconds. Now we are talking about microseconds, right? The second in terms of capacity, right? So how you can store more data within the same device or the size of the same device, right? So you need to be more innovation in terms of how you can have, you cannot have a bigger device and make the phone bigger, or your wearables bigger, right? So that's the second thing. And third is in terms of reliability, right? On how you want to make sure that your data is secure and you're getting those performance in terms of heat, temperature, or in terms of certain movements, because you're using it in cars, you're using it in so many other stuff. And the fourth, which I call, is more about the sustainability, right? So it is very environment friendly in terms of ESG, which is environment, social, and governance. So these are the focus areas for both semiconductor as well as mainly the data storage industry.
So you're talking about, when you talk about chip, you're talking about semiconductor industry, that how the size of the chip is getting smaller and smaller, and how much data we can store in that. So if you can talk more about that and what is happening in that industry. And in the past few years, we have seen a lot of you know you know disruption in the industry, like pandemic came, and that it disrupted industry in many ways. Like there was shortage of chips as well. So I want to start with what is trending in the fabrication industry, and how what is happening out there.
Sure. I'm glad that you asked this question about how difficult is it to manufacture a chip, because not many people really know about what it really goes through. In today's day and age, we are expecting things to be manufactured like in no time. So just to give a little bit of layman's perspective of a chip industry, right? It all starts with the only one ingredient, which is sand, which is a silicon dioxide, and you take out oxygen and to come up with just a silicon out of it, right? But the semiconductor wafer, which comes as a pure wafer manufacturing, is a very complex as well as very high capital intensive manufacturing, right? So what I mean by that is the reason why it gets complicated is because it goes through some 120 process cycles, right from the sand to get a chip. It is still not a complete chip; it's just a wafer that comes out of the end product. So the 120 process cycles will be equating to about 1700 steps, process steps to manufacture that, right? So if you take a very simple, 8-inch wafer, it should be as size as a 8-inch pizza, right? It goes through a lot of, depositions process. It goes through, etching. It goes through photo lithography, a lot of complicated process. And within that 8-inch, you end up manufacturing a wafer which is as thin as like 1/4 of your hair, you know. And when I talked about 1700 process steps, wafer in its journey, it almost goes about 30 miles or 48 kilometers that it moves within the fabrication unit in the processing steps, right? So it's as complicated. And to just get one wafer out of a factory, it nearly takes about 5 to 6 months, right? And now what we're talking about is just a wafer. If you remember your school days, you might have seen the periodic table, right? So there are about 36 elements in the periodic table, and we pretty much use the 30 elements of periodic table to manufacture a wafer. Now that wafer is just a plane which gets cut into dies, and you can produce as many as about 1,15,000 dies out of an 8-inch wafer. So it's very small, that goes into these devices. And after that, it goes through a lot of other test and assembly and test process, which is done by different other companies to come up with a final chip or an end product that goes into any of your devices as memory, right? Now, within this, obviously you've seen everybody talking about shortage in chip industry, right? Or shortage of chip in everything. The reason for that is because we are now using the chip in pretty much every content, right? Whether it's any device that you use today, with 5G coming in, everything can talk to anything, right? So there are a lot more intelligence that is needed, and that's why there is a shortage, right? And a lot of interventions are being done by different companies as well as different governments to ramp up the production of these semiconductor products, right? So that's what that makes it very complicated, because once you start with your input, there is a fixed output, so you cannot change anything in between. Or if you want to even employ a certain analytics on that, you imagine the complexity where you cannot just make those changes and get the results immediately. It takes time to even get into those mechanical yields or electrical yields, all those factors coming out of the wafer. So that makes it like very complicated.
So you talked about that the process, how complex the process is in the manufacturing industry, chip manufacturing industry. So in that case, how do you scale analytics when it comes to implementing analytics in the manufacturing industry, and how do you use in your product?
Okay. So, great question, by the way, because I just described you the complexity of our whole manufacturing process, right? So, I'll just like to step out of just pure play, chip as well as the wafer to rest of the, products within the data storage, right? So, if you look at your question, one is about how do we implement, what are the use cases typically, and then do we also have some analytics within our own products as well, right? So yes, one of the reasons why it is so difficult is number one is just because of the size of the products that we work on, right? So I described that the wafer that comes out as a die is as big as like 1/4 size of your hair, right? Second is you're talking about very complicated process steps that it goes through in a clean room where you cannot really have a lot of it has to be pretty very clear in terms of that cannot have any defects, right? Um, and the third is that it takes significant amount of time because once these products go onto the line to get manufactured, as I mentioned, the outcome is pretty much fixed. So if you want to suggest a change or if you want to read through a data, it takes significant time for you to implement it. One is about just doing certain POCs, building models, and making sure that your solution really works. But the deployment will take significant time because it might be a case where you want to. It can be a maintenance of your machines, right, or your fixtures, or it can be altogether where you want to change certain process step, right? So that makes it complex and pretty long cycles to implement analytics in this space. The other thing I would call is since it goes through a significant number of process steps, there's a lot more data, parametric data that comes out of it, right? So we're talking about a table that contains about 3,000 columns. A lot of important features that comes in helps you to predict the outcome. So you need to have a very established big data platform, both getting the edge computing, helping you to propel those data into the data warehousing, which is again running on your big data platform, and then very robust pipeline in terms of your making sure you have very high latency or to low latency requirements to feed it into your machine learning algorithm, right? So this makes this process very, very much complex. Now, to second part of your question, like analytics within your product, I think we are getting there because the storage devices are also becoming, data storage devices are becoming much more smarter. One of the example that I can give you is, either we can build certain AI capability within the product that helps you to make decisions much earlier in the game, right? So you can all say that, hey, I have a memory in my watch, I have memory in my phone, or in the drone, or let's say in surveillance devices, but you don't want to really do an after the fact analysis, but really want to catch that much earlier in the game. What I mean by that is, let's say I have a surveillance camera, right, or a rescue drone. So if there is any crime that happens or any mishandling that happens, then you go back to your CCTV and look at the images and videos for the past 1 month or whatever that the period is, and try to analyze and say that this is what happened. So you're telling what already happened, right? You're not predicting it. You're still in that descriptive kind of zone. So we want that to get smarter. You don't have like a security personnel looking at multiple monitors and figuring out what is happening, right? So the expectation is that with the surveillance camera, which is a very growing market, today it's about $42 billion, it's going to be about $87 billion market by 2027, right? So what we are doing is we are getting a micro memory device, which is also called as MLA, which is the machine learning accelerator. So it reads the information and detects certain certain anomalies as well as certain actionable insights that it can send to the cloud computing. What I mean is, let's say you have a surveillance camera and there's a person that walks by, right? So you can have CCTV in your front yard, in your entrance, exit, backyard, a lot of places. Now, when it sees a motion, it detects a motion. So the moment it detects a motion, it should know that, hey, this is a person, or this is a vehicle, or this is an animal, who passed by, right? And let's say if it is a person, then it wants to know whether it's your employee, or whether it's your family member, or whether it's a visitor, is a guest, those sort of things, right? And that decision has to be made immediately, so that you can give the insights to the cloud, where it can take certain actions like unlocking the door, or making, maybe blocking it, because you will figure out whether the person is of your interest or not. So it cannot be that you will go the next day and figure out what's happening. So you want a lot more intelligence. So we are coming with those products as well, which is embedded within our micro devices, right? So similarly, there is a lot more technology in terms of, I talked about the capacity, I talked about the accessibility. So it has to be much faster.
Yeah.
So new technologies like non-volatile memory express, which kind of immediately fastens your integration between your devices and your cloud, cloud computing or cloud storages as well, right? So those are some of the products that the data storage industry is coming up, and specifically the MLA that I talked about is a Western Digital product. So one more point I would like to add to conclude this statement is, when I talked about the products being so small, we have solutions where we also kind of detect if there is anomaly within those products, because within that 1/4 size of your hair, there are certain etches where we make those connections for the transistors. So we use CNN methods and computer vision to even detect those anomalies within those products. So imagine that, how complex it is to build a solution around that, right? And for that, we take a lot of images of the products when they are getting manufactured, and we get almost like 1 million images per month as unstructured data that we have to analyze. So it's, again, GPUs needed, high storage, very good big data platform solutions, and the complete strategy that is required to develop solutions in this space.
Yeah, so we were also discussing about the shortage of chips, and that happened during the pandemic, and it has not been recovered yet.
Yeah.
So what are the interventions you saw from companies and from governments in that respect?
Okay. Yeah, I mean, that's true. A lot more, intelligent devices or smart devices that emerged in the last few years, and which has created this, unending or unsatiated demand of semiconductor chips. It's a good problem, but obviously it's hitting a lot more revenue targets for companies, which could have, it's kind of a lost opportunity for many companies, right? So again, they don't want to leave it too long. They want to make sure that it doesn't have a very long tail in terms of revenue losses. So you need to have some mechanism to start building and producing more chips, right? Especially in automotive industry, which it has much more demand generation, as well as 5G that we talked about, right? Now, so you talked about some of the interventions. So, recently you might have heard about, U.S. government, like Joe Biden administration came up with the, chip bill. Essentially, they are again investing, making sure that, we are having an R&D as well as, U.S.-based manufacturing. So they are providing a lot of subsidies. They're giving up to $52 billion of subsidies to help establish the semiconductor demand, fulfill that demand, right, within the U.S. So that's one. And second is, even from Japan perspective, Japan wants now, the government is focused on manufacturing a 2 nanometer chip, and they are investing about a lot of money in terms of helping people invest into both technology inventions, as well as, which is R&D purpose, as well as producing that in Japan itself, right? And one of the things that Western Digital also did was, we kind of have a joint venture with Kioxia, and where the government has kind of helping us with about 92 billion yen, Japanese yen, of investment to establish a fabrication unit there, right? So the reason for that is, I talked about the size, the capacity, and all those things, right? Just think about example where, let's say you're living in a home. You're probably 2 members, and then you become 3 or 4 members, and then you feel that, okay, that house is not sufficient. Probably you go and build another one which will have 2 stories to it, or make it a duplex, right? When that is not sufficient, people will build in a higher floor building, right? The same thing happens with the semiconductor, where with a 3-dimension NAND, which is not AND gate. So where we are trying to develop multi-layer memory chips, which can use the same size form factors, but have much more capacity, right?
Okay.
So those are the investments that are happening in that, right? That is in Japan. And recently, we also had the Silicon India Summit here in Bangalore, where Indian government is kind of investing about $30 billion of investments into building the fabs as well as the display units, right? So these are some of the interventions that the companies are doing as well as the governments, because everybody feels the need of that and they want to catch on to the the demand wave, right? And just write that to make sure that you're fulfilling that. So one last thing that I would like to add, in addition to we talked about the capacity, size, form factors, right, and some of the investment being done. One more angle which was not so prominent so far, which all the companies are now focusing on and the governments are focusing on, is the sustainability, right? So, and that's where this AI and advanced analytics really come in, because as part of the sustainability, you need to have products that are environment friendly, right? So I would one example I could quote from Western Digital itself is, we are now manufacturing hard disks which used to have which used to use air instead of we are using helium, which is like 1/7 the weight or density of plain air. So with that, you were able to manufacture and with a smaller size products, devices that can fit into the same rack space, like more devices in the same rack space, right? So every company is now focusing, they're investing a lot in those sustainability goals in terms of making it a clean manufacturing to the environment, right? So that is, again, you need a lot of advanced analytics to do that kind of interventions.
So very interesting to know that India is investing so much money in its, in establishing the fabrication industry. So I wanted to know that, what is the scope for India in this particular industry, and how difficult or easy it's to establish the whole ecosystem in the country.
Yeah, I mean that great that India is investing so much into semiconductor, but it's easier said than done, right? And we all understand that it's very complex in terms of establishing ecosystem. What I really mean by ecosystem is, like, if you just take a automotive, right, and you want to manufacture a car, let's say Kias of the world or Hondas of the world want to now manufacture in India. When they came in, there was already an ecosystem developed, because it was Maruti which was manufacturing cars. You had some other external players also doing it. So you had an ecosystem in terms of your suppliers, your MRO units, a lot more multi-tier vendors, right? But when it comes to a semiconductor, we probably have only design engineers, right? We did not have an ecosystem where we are developing and manufacturing the semicon. So that makes it a little more complicated to do that in India. But having said that, I think the administration and the government is very focused in doing that. And you already seen some of the articles as well as news about Vedanta and Foxconn already establishing a display manufacturing unit. So to give you a perspective of what is happening in India, right? So as part of Make in India Atmanirbhar Yojana, so they wanted to focus on ESDM, which is electronic system and design and display manufacturing, right? Which involves you to have certain fabrication units within India, display manufacturing within India. You want to make sure that you have a talent pool, which is India is the skill capital for this. We are also investing in the design, within India, and also the R&D, because unless you do the R&D, you will not be able to obviously come up with more innovations, right? So these are the four pillars under that initiatives. Now, under that, as I said, like, government is investing about $30 billion. So out of that, the $10 billion is being invested on more on the display manufacturing part of semiconductor, and other 7 on pure semicon, and about 13 in the assisted manufacturing. That means anything that assists you in manufacturing the semiconductor as well as display manufacturing, right? Now, why it is complex is because number one is to find a credible partner, right? Because you need somebody externally to come in and establish that. Now, India cannot just have somebody just build that. Like similarly, how Vedanta is now partnering with Foxconn, so you need to have some credible partner that can come. who has the knowledge, they have the technological know-how of manufacturing. The second aspect is in terms of the skill. You want to make sure that you have people who are extremely skilled to manufacture. To just give an example, just to set up the fab, it takes about 18 to 24 months. It's bare metal, right, with just the tools and devices. But to reach the capacity, it takes about another 12 to 18 months. So we're talking about a 4 years journey to be really at capacity, right? The other challenge is you need a lot of uninterrupted power, which is electricity. You need water, chemicals, and you have to have a very relaxed custom rules to get some of these products in and out of India, right? So, and the fourth is I mentioned about the R&D, right? Unless you establish an R&D facilities, because a lot of companies within India will do R&D, but not significantly on the entire product, right? So you need to get into that aspects, where you have more autonomy in terms of developing that products, then you can do that. But so far it has been a very great move, and a lot of companies have already started doing that. So hopefully we'll see more fabs as well as display manufacturing coming in the next couple of years.
So, what are the underpinnings of success and challenges in the advanced analytics that you would like to share with our viewers in the high-tech industry?
Yeah, sure. Every industry has its own challenges and success factors, right? And we are no different. High-tech industry. When I talk about high-tech industry, it can be semiconductor, it can be OEMs like Cisco's of the world, Junipers of the world, who make those network devices, or it can be even certain component makers or even distributors, right? Everybody has their own challenge, I think. But the challenge with respect to companies which has in-house manufacturing, right? So if you look at it, majority of the companies within high-tech space have an outsourced manufacturing. They only own the design, but manufacturing is done by somebody. Like, for example, Cisco, if you look at it, majority of manufacturing is done by Foxconn or JBL of the world and all. They own the design, right? But within our company, we pretty much do like everything, because it's, as I said, it's very high capital intensive and very complicated, so you cannot really train and establish that very quickly, right? Now, what the challenges with that in terms of underpinning challenges in establishing the analytics is one is the domain knowledge, right? Because you need to be really choosy of what you can do as a analytics function, and what it is better for a business or the engineering team to run certain analytics by themselves. Because if you ask me about physics or thermal engineering, probably I or somebody else, data scientist, might not know it. So if you're getting very deep into that, maybe it's better to be done at a business function. But anything that related to manufacturing, the yield improvement, I talk about cost reductions and all those things, then the analytics team or the central team can do it, centralized team can do it. So it's domain knowledge, which is very significant. The second, I would call it as in terms of your talent, for scaling purpose, right? So you need to look at creating those analytics team which are able to interact with the business, because since you don't really have that knowledge, because that's where a lot of companies come up with this AI interpreter role, right, where they're establishing the connection between the data scientist and the business. So we call that as a ABP, or a analytic business partner, which help with making sure that the program is delivered, right? The third challenge that I would talk about is in terms of how do you really manage data, right? It's not about just having the analytics team, but you need to establish that entire data pipeline, with all the latency requirements that you have, because we are getting those images from the manufacturing with the parametric data. I talked about tables having 3,000 columns, right? So how quickly can you get it? How quickly can you compute it? So it has to be a very thoroughly established structure in terms of your data, which is a big data platform, right? And the last thing that I would do is that, since it's significant long cycle that it takes to implement, we would like to make certain small wins, get small wins instead of one run instead of a sixer, right? So it takes time for you to get there, so that people or the business can get a lot more comfortable. There's credibility that is generated. So I feel that, and that's how you kind of scale the solution across. And the last but not the least, which I have discovered right with my experience so far, is the ML ops, right? So you need to democratize this whole analytics within your industry. So the way to do that is how can you give more power and self-service capabilities to business modelers rather than making it as an analytics team, right? So for that, you need to remove the complexity of building the pipeline or building the whole CI/CD models and all those things. So that's why it's very important for you to go on to an ML ops where the cycles are much quicker. It's more configuration based, and instead of spending like 8 months, you can probably do it in like 4 months, right? So those are some of the typical challenges and some of the I would say solutions to what we see in the high tech, especially with in-house manufacturing.
Cool. Seems that we are living in a very interesting age and about to witness newer developments in the analytics and semiconductor industry. So thank you for joining us, and I hope that this conversation will be fruitful for our viewers as well.
No, absolutely, and glad that I'm here, and thanks for the opportunity. I think you rightly said, it's plethora of opportunities that are coming in, especially with this space. And I wanted to make sure that people understand this industry, and there's just the data storage industry, and then there's multiple possibilities within the analytics in this, right? So glad to be here and enjoy the conversation.
Thank you.